Today we're going to be conducting an experiment to see which type of flour produces the best sourdough starter. We're going to be using the low waste starter method. I'm not an expert at making starter. This is only my third time making my own. I wanted to use the low waste method. That way we don't have as much discard and we don't need as many supplies. Why should you make your own sourdough starter? Simple. When you do this, you're activating all of the yeast that are already in the bread themselves, cultivating them, and creating a fermentation process which allows you to make bread. This will allow you to make a bread that only needs 3 ingredients. It's made more the way our ancients did. It's just flour, water, and salt. Sourdough bread is easier to digest by your GI system because the lactic acid helps break down some of those proteins. Even people with some gluten sensitivities can tolerate sourdough bread because the yeast help break down some of that gluten. I didn't say gluten intolerance. That's a different story. Oh, sorry, that wasn't part of the process. I was just getting my morning coffee. To make our starter, we need a scale, but I will provide the measurements in cups, so if you do not have a scale, you can still do this. We need room temperature water, and this is just filtered water from my fridge that I left out overnight to let the chlorine evaporate out, because the chlorine will kill the yeast that we want and need to cultivate to get our bread to rise, because ultimately we want to make bread with our sourdough starter. We need a silicone spatula, a spoon, and I'm using plastic chopstick because I have 3 different flours that we're going to be testing. One is organic, unbleached, all-purpose flour. The other one is your regular all-purpose flour, which is bleached enriched all-purpose flour. And the third is non-organic whole wheat flour. And then I have containers to put those in respectively. For each jar, we're going to use 40 grams of flour and 40 grams of water, so equal parts in weight. But it's not equal measurements in cups. That is 1/3 cup of flour and 1/8 cup of water per jar. We're going to put the flour and the water in the jars and then stir until combined. For days 1 through 3, we're just going to stir it twice a day. And then once we start seeing activity in the jars, by activity I mean bubble, then we'll start adding more flour and more water and taking some of that starter away for the discard. But you don't want to discard it. You can look up so many recipes to use it in. For example, I just add it to my pancakes, or if I have enough, I make sourdough pancakes. Otherwise, I just add it to my regular pancake batter. But you can look up so many recipes of what to do with your sourdough starter. I've even made banana bread with it. It comes out really good. So there's no need to throw that away. You can add it to something else. The ratios I'm using, I actually am copying from a video I saw on YouTube, and it is this little farmhouse where she explained the low waste starter method. And we want to do low waste in order to throw less away and in order to require less ingredients, because right now we're still under social distancing guidelines, so the less wasteful we are, the better. And that applies all the time, but especially right now when you are not running to the grocery store anytime you're missing a single ingredient. Once your starter is mixed, you want to put it away at room temperature, somewhere dark. It doesn't like direct sunlight. I just use a pantry cabinet.
Oh, sorry about that. A couple of my lab mice got out of their cages, and those 2 are so bad. The last time they escaped from their cages, they ate all of the sugar that we were going to be using in a different experiment, so I had to make sure to lock them back up.
And know that we're not mixing things up. So our cups with our labels on them for our specific flours. We're also labeled on this side to ensure that everything remains uncompromised. The worst thing in the lab is when you forget to label. Oh, horrible. Okay, that is definitely a rookie mistake that I'll never make again. I'm going to start with the organic, unbleached, all-purpose flour. Zero our scale to make sure the weight of the jar is accounted for. Then we'll add 40 grams of water. Next, we'll add the 40 grams of organic, unbleached, all-purpose flour. 40 grams of flour is about 1/3 of a cup. 40 grams of water is about 1/8 of a cup. Make sure you're wiping your spoon or measuring cup or whatever you're using between uses to to make sure that we remove as much of the previous flour's residue as you can. And then we just stir this up. You can use your plastic spatula to wipe down the sides if you really want it to be nice and clean and you don't want your edges to get too crusty. Flatten, smooth out that starter a little bit. That's what that looks like while it's nice and mixed. My jars came with these little lids, but you don't want to completely seal it. So I'm just going to lay it right on top, just to keep any bugs out. My next one is the Bleached Enriched all-purpose flour, which is just your regular all-purpose flour, the generic kind. It's usually bleached and enriched. Enriched just means they add a couple of nutrients that tend to be missing in the traditional American diet. Then we add 40 grams of water. Bleached Enriched all-purpose flour. Wipe off the spoon again to remove any of that previous flour's residue. We stir it up. Then the last one, non-organic whole wheat flour. Zero the scale, add 40 grams of water. It's not perfect enough. Do this again. Then non-organic whole wheat flour. Our hands finally wanted to act scientific. And already I can see that this whole wheat flour is taking more water than the other ones. It's definitely thicker, even though our ratios were the same. Flatten that out a bit. To mark the levels of your starter and its growth once it starts growing, you can either use a rubber band or clean hair ties just around the cup at the levels that you are currently at. I like to use a dry erase marker. Since I'm using glass, it just comes right off. See how much thicker that is than the other mix. Place our cup on top. Actually, I'm going to go ahead and draw the lines at the level our starters are currently at. Just right here. This is the bleached enriched flour, nutritional all-purpose. We are about there. And this one is the organic unbleached all-purpose flour. And we are around there. We'll put those away in a room temperature, dark area. As I mentioned, I just do the pantry. Again, for days 1 through 3, we only stir them every 12 hours. So a morning stir and a PM stir on the first 3 days. We wait until we start seeing bubbles to add more flour, more water, and do any discarding. Let's take a couple of notes here. There we go. We will check back in for our afternoon stir. Time for the afternoon stir. And when you're doing this at home, you can make it work around your schedule, like before work and after work. It doesn't have to be an exact 12 hours. Because I'm doing an experiment, I want to make sure that I'm doing the same thing for all 3 of my mixtures at a consistent time. That way there are less variables. So let's give the first one a stir. The first one is the Bleached Enriched all-purpose flour. As the days progress, you will notice that your mixtures are going to start smelling a little sour, kind of like sauerkraut, like yeasty sauerkraut. That's normal. If you see any growths of mold or black or anything like that, then you'll want to discard your mixtures. The next mixture is the organic, unbleached, all-purpose flour. The last flour is the non-organic whole wheat flour. As we saw earlier, this mixture was thick even with the same 40 grams of water that the other flours received. And that is really balling up. So just kind of level that out in order to mark. Now we're going to mark the levels of the mixtures once again. We'll get those back in storage until it's time to stir again in the morning.
Do you guys see what I see? We actually have some activity already. It's only been day 1. This is day 2 of our experiment. We're going to do our morning stir and then put it back in the cabinet. We weren't expecting to see activity yet, so we're not going to feed it yet. We'll give it at least another day because the flour and the water is all pretty new in there, so the yeast should have plenty of food still. We shouldn't have to feed it just yet unless this is super yeast. We'll see. There's where the line was marked, and that's how much growth we've already gotten. This is the organic, unbleached, all-purpose flour. We'll stir that up first, and this time I'm actually going to use my spatula to clean off the sides so we can really gauge the growth. And I'm going to remove my dry erase marker line and put a new one since we have a new level. And look at that, that's nice and sticky. Almost feels like homemade marshmallow. Alright, I'm going to clean up the edge. That way we can really gauge our growth. Another thing you want to do throughout this process is you just want to sniff your mixtures. You want to make sure that it doesn't smell bad. It could smell sour, it could smell yeasty, but it shouldn't smell bad. If you see any colorful growth, like fuzzy growth, green or white or black, then that's mold and you need to throw that away and start over. Let's smell it. It smells like flour and water. It smells like flour and water. Doesn't really smell like anything yet, but this is the only one that doesn't really have any activity, our non-organic whole wheat. Next is the Bleached Enriched all-purpose flour, and you can see that has bubbles in it as well. You can see the bubbles on the outside where our line was marked from yesterday and the amount of growth we've got overnight. You may have gotten more activity so fast because my kitchen is very warm. It's been really hot the last couple of days here. We're in Southern California. The air conditioning is on, of course, but we don't keep our house very cold. I'm going to clean the spatula so I can use it on the next one without contaminating. I mentioned before that you only stir twice a day for the first 3 days. You don't add or take away anything at that point. But since our yeast is alive, we might have to do earlier feedings. We want to keep it happy. And then the non-organic whole wheat flour. And as you can see, the level is still where we put the marker line. No change there. No bubbles on the surface. Give it a stir. If you don't see activity in your mixtures, you can give it up to 10 days. After 10 days, you should really throw it out and start over. But don't give up on it too fast. And it could take 7 to 10 days to have starter mixture that is active enough to actually bake bread with. You know your starter is ready to actually bake bread with once it can double in size within 4 to 8 hours. Then that means you have enough yeast that is active enough to support a loaf of bread. Work that back down. We'll put these guys away in their room temperature space again, which is my fancy pantry, and we will check back again tonight for our evening stir. Day 2, afternoon stir. At this point, the whole wheat starter mixture also has a lot of bubbles. The bleached enriched all-purpose flour also has a lot of bubbles. And the organic unbleached all-purpose flour also has a lot of bubbles. So far, all of the starters are taken off sooner than anticipated. Next, we'll stir the bleached enriched all-purpose flour. And that's our whole wheat flour.
We'll give these a sniff to make sure that they still smell doughy, but not bad. They can smell sour, kind of like sauerkraut, or they can just smell yeasty. You don't want to smell acetone, and you don't want to smell any kind of like alcohol smell coming out of those. If you do, it means that your starter needs more food, which is more flour and water. So let's give these a sniff. It smells fine. This one, the bleached enriched all-purpose flour, probably has the ripest smell. It's starting to get a little sour. We're probably gonna have to feed these tomorrow. I had said earlier that we would do just stirring twice a day for days 1 through 3 and start feeding on day 4 if we saw activity. I'm starting to see good activity in all of them already. I'm going to go ahead and start feeding them on day 3. We'll mark our new levels with this dry erase marker. We'll put these away in a room temperature dark area, aka my pantry. Here at MSG Labs, we really pride ourselves in our scientific advancements and our exceptional results. These starters are fitting that picture. Here's the whole wheat flour. We got some good activity. Here's the line marking where the level of starter was after our PM stir for day 2. It is now day 3. Mornings, and we've gotten so much growth. The organic all-purpose flour settled down a little bit, not too much growth compared to yesterday. A few bubbles on the surface, so we're still having activity, which means our yeasts are active and alive and eating the starches in the flour. This is our bleached enriched all-purpose flour, or just generic all-purpose flour. Also have bubbles there. Because we have activity in all 3 of our mixtures, today we're going to remove some of this starter and give it a feeding. And to feed it, we're going to use 40 grams of flour and 40 grams of water. Again, 40 grams of flour is 1/3 cup, and 40 grams of water is 1/8 of a cup for those of you who do not have a scale. We're going to leave about 2 tablespoons of starter in each container and then replenish it with the new flour and the new water. Again, I'm using dechlorinated water, which I dechlorinated by allowing it to just sit overnight covered and the chlorine evaporated out naturally. We're going to be collecting the discard in this bowl, but we won't be discarding it per se. I'm going to use it to make some very scientific sourdough pancakes. We took away 56 grams of starter. We're going to take away the same amount for the other containers. Negative 56. First, we'll measure 40 grams of water. Next, I will measure 40 grams of each respective flour. We will start with the whole wheat flour. Make sure you're using clean laboratory instruments every time. Stir our mixture. As I saw before, the flour accepts a lot of water. Next, we will do the organic unbleached all-purpose flour. Here we are, organic unbleached all-purpose flour, 40 grams. mixture later. That's the bleached enriched all-purpose flour, 40 grams. Stir it up. Now I will store these in a room temperature, dark environment until tomorrow. Now that we've started feeding them, we don't have to do the stirring twice a day. If you want to do the stirring twice a day, by all means you can. You won't hurt your starter, but it isn't necessary as now it's getting fresh food stirred into it every day. I'm going to mark the levels of our starter in order to keep track of all of the growth. I will be back with these tomorrow morning. Day number 4, and time to replenish our starters again. Time to stir these up, and today we're going to name them since we're seeing good activity on them already, and we name them in hopes of keeping them alive and for them to be strong. So my whole wheat starter mixture I'm going to name May Carol Jemison, who was an engineer, physician, and former NASA astronaut. In 1992, Dr. Jemison became the first Black female to travel into space. You can't rise any higher than space, and we definitely want our breads to rise. So this is Dr. Jemison. Literally touch a little bit. This one's pretty thick. Next, our bleached enriched sourdough starter. We're going to name her France Cordova. She's an astrophysicist. She served as the director of our National Science Foundation. Dr. Cordova conducted important research on X-rays and gamma ray sources, accretion disks, and black holes. Hooray for women in leadership positions and science. Our organic, unbleached, all-purpose starter is going to be named Nancy Silverton. Nancy Silverton was the first chef to win James Beard Awards for both Outstanding Pastry Chef and Outstanding Chef. Chef Nancy is the owner of La Brea Bakery, which started here in Southern California. And we definitely want our breads to be yummy and outstanding. Let's officially name them. This is our whole wheat starter. Meet Dr. Jemison. Mark our level, not with a permanent marker, with a dry erase marker. Erase the old level, and there we go. Introducing Dr. Cordova. And last but not least, the organic, unbleached, all-purpose flour is Chef Silverton. Introducing Chef Silverton. Mark the new level. We will put these back in their dark room temperature environment until tomorrow. See you then. Good morning. It's day 5 of our experiment. Cut to the lab bench. Good morning, Dr. Jemison. Good morning, Dr. Cordova. And good morning, Chef Silverton. So there's activity in every one of our jars, but our whole wheat flour, Dr. Jemison, is still going above and reaching higher heights than our other two.
Time for our ladies to go back in the pantry. See you guys again tomorrow for day 6 feeding. Hello, and welcome to day 6 of our experiment. I have decided to end the experiment a little early because Dr. Jemison is doing so much better than the other 2 starters. As you can see here, I've marked the lines from yesterday's growth to today, and it has more than doubled in size. Dr. Cordova and Chef Silverton are also doing great. They've risen to about the same levels, have activity, bubbles at the surface. I have decided to conclude the study a little early in order to not waste any more resources. If I find a friend or colleague who wants these starters, I will continue to feed them until they get strong enough to sustain a loaf of bread, which means that they will double in size within 4 to 12 hours. So they just need more feedings and they need more time. They would get there eventually because they're showing decent activity. But if I don't find someone that wants them and we don't need them here at my lab, then there's no need to continue to feed them. All 3 of these are wheat flours. You have to kind of look at the structure of the wheat. A wheat kernel is made up of the bran, the endosperm, and the germ. A whole wheat retains those 3 components, the bran, the endosperm, and the germ. It's minimally processed, which leaves behind more nutrients and more microbes in that flour itself, which once we wake up that yeast and start to cultivate it, those nutrients are there for the yeast to consume and multiply and grow. In all-purpose flour, the bran and the germ components of the kernel are removed, leaving behind only the endosperm. And then with the bleached all-purpose flour, they take away the bran and the germ, as well as it goes through a further bleaching process, creating a softer flour, typically reserved for fancy pastries, delicate pastries, not necessarily for breads, but more for pastry baking. Bleached all-purpose flour contains only the endosperm, and it also undergoes a further process of bleaching, which depletes microbes like yeast, which is what we need to wake up and multiply and cultivate in order to get a good starter. If you're keeping your starter at room temperature, you want to continue to feed it at least once a day at the point of maximum activity to make sure that it doesn't run out of starches. Once a starter runs out of starches, it'll become proteolytic, which means it'll start to break down the proteins in the flour and your mixture will become pretty soupy. It weakens the starter to where it starts to lose the bubbles because it can't hold it because there isn't enough protein left since it's been broken down by the fermentation process to hold the bubbles and retain that structure. In conclusion, Dr. Jemison wins this experiment. Hopefully you guys check back in for our next experiment. From MSG Labs, signing off.